Chrysler's TC by Maserati. Truly a world-class automobile, a blending of Italian craftsmanship and American engineering. A luxury sport coupe whose stunning style is hand-hewn by Maserati coachworkers who meticulously form, fit, and finish automobiles to exacting standards. Chrysler's TC by Maserati offers an unmatched level of luxury. It can be seen, felt, and even smelled in the hand-stitched, soft Italian leather throughout the interior. The leather-upholstered power seats, fully carpeted rear compartment, dual electric remote control mirrors, compact disc player, and a seemingly endless list of standard features make this new sport coupe the most exclusive product ever offered by Chrysler Corporation dealers. Its fully instrumented gauge package, coupled with an optional 16-valve intercooled turbocharged 200 horsepower engine and 5-speed transaxle built by Getrag, a German company which also supplies BMW, Mercedes-Benz, Porsche, and Jaguar, give the TC a sporting capability demanded by a select group of owners. The Chrysler TC is truly an international product. From the United States, some 1,200 parts are shipped to Maserati's plant in Milan, Italy. Body parts come from Torino. From Modena comes the exotic 16-valve engine. And from various points in Europe come a host of specially created components. In Milan, the TC is assembled, painted, and final trimmed. The cars are then taken to Germany, where they are shipped to Benicia, California, and Jacksonville, Florida. Upon arrival at the selling dealer, the car is complete, but for the removal of various protective coverings on the body and interior. Preparing the TC for delivery is only one job you, as a Chrysler dealership service department representative, must assume. Another equally important job may be a little unusual for you. So before we proceed with the complete introduction of the TC, let's spend a few minutes reviewing it. The TC carries a price tag higher than any other car Chrysler has ever sold. This, plus the connection with Maserati, means that the typical TC customer is not the same person as a typical Chrysler, Plymouth, or Dodge customer. TC owners will expect special consideration and special handling to be satisfied. They will have different needs than what you're probably used to, and they will expect you to act and perform like a professional. So here are a few tips you should keep in mind when servicing a TC or when talking with a TC buyer. First, recognize that they will expect their cars to work perfectly all the time. When service is required, their main goal is to have the car fixed quickly and correctly. Cost will be less important than time and quality. Many TC buyers will not be familiar with Chrysler products. They don't know the controls. They don't know how to operate the accessories. And they're not familiar with a dealership. This is a fast track to frustration. That's why it's so important to thoroughly introduce the owner not just to the car itself, but to the service department as well. The purchase of a TC should be an exciting, rewarding experience. Don't make claims that either the car or your service department can't match. Buyers of this type of automobile can move easily to a competitive product if their expectations are not met. The best way to talk with TC owners is to be straightforward. Give accurate estimates of when repairs will be completed and be candid about what the owner can expect. If an appointment is made, keep it. If you promise to call the owner, make the call. The TC costs a lot of money. People who can afford one are used to being treated professionally. In their jobs and in their homes, they command respect. When a TC owner comes into the service department, you should go out of your way to be courteous and helpful. Owning a TC doesn't make the driver an automotive enthusiast. Don't expect TC owners to be able to accurately describe problems or diagnose solutions. That's still your job. When an owner brings the car in for service, make sure you listen carefully to what is said and ask the questions you need to identify the real problem. That's the first step in fixing the car right the first time. TC owners, particularly those who are unfamiliar with your dealership, must be convinced that your word and your work can be trusted. Once it's been established, the owner's confidence in your abilities can lead to a long and pleasant relationship. Enough said. Now let's take a look at Chrysler's TC by Maserati. As you'll see, there are many similarities with the Chrysler LeBaron convertible. But there are also enough differences to make the TC a truly unique product. The car has a 93-inch wheelbase and an overall height of 51.9 inches. Curb weight is 3,085 pounds. The brake system features power four-wheel discs with anti-lock by Teves. Steering is power-assisted rack and pinion. The suspension is a dual-path iso-strut system on the front and a trailing arm beam axle with coil springs on the rear. Gas pressurized shocks specifically tuned for the TC are on all four corners. The standard TC engine is the 2.2-liter turbocharged intercooled Turbo 2 found in the Dodge Daytona Shelby, derated slightly to allow use with an automatic transaxle. Chrysler's A413 automatic transaxle is standard with this engine. The optional powertrain, the one that really sets the TC apart, is a Maserati-built 16-valve turbocharged intercooled 2.2-liter four-cylinder engine. This engine is capable of developing 200 horsepower at 5,500 RPM, compared with the 160 horsepower at 5,200 RPM rating of the Turbo 2. Torque is 220 pounds-feet at 3,400 RPM, compared with the Turbo 2 torque of 171 pounds-feet at 3,600 RPM. In a word, this engine is designed for performance. 0 to 60 is timed at 8.3 seconds, about half a second quicker than the very quick and lighter Turbo 2. Besides the 16-valve engine and 5-speed transaxle, the only other option offered on the TC is exterior colors. There are 5. One of the most unusual designs of the TC are the 2 standard tops. There is a body-colored, removable hardtop that has tinted fixed glass rear and opera windows and an electric rear window defroster. A 6-point latching system secures the attachment. There is also a standard soft folding top featuring a thin silhouette-type design that stores out of sight under a metal tonneau cover. This concludes part 1 of this videotape presentation. To get the most benefit, you should stop the videotape now and turn to part 1 in the reference book. Once you've reviewed the information there, you may either rewind the tape and watch this part again, or you may proceed with the next section, New Vehicle Preparation. The first few minutes, hours, and days new owners spend with their cars are often the most important when it comes to satisfaction. The excitement, the thrill, the anticipation of driving a car that looks, smells, and feels brand new can quickly be ruined by inadequate road-ready procedures. Chrysler's TC by Maserati buyers in particular expect their new cars to be exceptionally well prepared. After all, they've paid a premium price for the TC, and they expect premium service. That means you should give special attention not just to the standard items, but to the small details as well. Remember, the TC is assembled in Italy and shipped to the U.S. from a port in Germany. Before it ever reaches the owner's hands, the car has already traveled several thousand miles. Every modern effort has been made to protect the TC during shipment, but the quality of the final delivered product is in your hands. The new owner's satisfaction during those first few critical miles behind the wheel is very much up to you. Owners will measure their previous experiences with luxury vehicles, both import and domestic, against the TC. Through your attention to details, we will prove to these owners that Chrysler's TC by Maserati deserves its ranking as one of the world's finest automobiles. Most of the road-ready procedures you're already familiar with. There aren't a lot of new steps to learn. In fact, you can follow the guidelines published in the Road Ready Manual as you prepare the car. When the TC arrives at the port of entry, several pre-delivery procedures are performed, such as the removal of styrofoam bumper protectors and the installation of the Infinity 2 radio system. Here are the items you'll have to remove. First, there are 2 plastic door edge guards. There are 2 door sill plates. Remove the 2 body side molding protective covers and the 2 bright B-post molding covers. Remove the 4 wheel lip molding covers. A cover on the tonneau cover molding must be removed. Remove the bright grille bezel cover. There are plastic and bright bumper fillers at the front and rear bumpers. Inside the car, remove the 2 door trim pads and the console top cover protection. Uncover the 2 leather seats. Remove the steering wheel cover, the carpet protection, and the 2 sun visor sleeves. Then remove the gear shift knob cover. The remainder of the new vehicle prep services are the same as you perform on other Chrysler cars. This includes the under-hood services, such as connecting the IOD on the body and under the vehicle. Remember to adjust the tire pressures to specification. This is critical to the handling of the car. Install the items shipped loose, including the cigar lighter, spare tire cover, toolkit, and umbrella. Make certain to inspect both the convertible top and the hard top. In most cases, no adjustment to either top will be necessary. The procedures for leak testing and adjusting the tops are discussed in detail later in this video presentation. The final road test before delivery is your own personal way of assuring quality. Sometimes it's only by the seat of your pants that you can locate a problem. Listen for rattles or squeaks. Feel for vibration. Try to find any small detail that can be fixed before the car is delivered. Remember, the TC buyer expects to take delivery of a car that is in nothing less than perfect condition. You are the expert that can assure the buyer's satisfaction. This concludes part 2 of this videotape presentation. To get the most benefit, you should stop the videotape now and turn to part 2 in the reference book. Once you've reviewed the information there, you may either rewind the tape and watch this part again, or you may proceed with the next section, the Teves anti-lock brake system. The Teves anti-lock braking system is standard on the Chrysler TC. It is designed to provide increased vehicle stability and brake performance under most braking conditions. The system allows the car to be stopped in the shortest possible distance, regardless of road surface material, road surface condition, axle load distribution, fast changes in friction between the tire and the road, or braking in a turn. The Teves ABS system uses an electronic brake control module, or EBCM, which processes signals received from inductive sensors located at each wheel. These sensors measure the speed of each wheel. By comparing the signals received with those in memory, the EBCM is able to determine if one or more wheels are tending to lock. When this condition occurs, solenoid valves open and close to adjust the hydraulic pressure in the part of the circuit acting on the locking wheel. In other words, the EBCM removes pressure from the caliper of the locking wheel and then restores pressure when the wheel is no longer locked. pressure is increased at the wheel positions that are not locked. This sequence of pressure on, pressure reduce, and pressure maintain occurs very rapidly, much faster than a driver could pump the brake pedal. The sequence is repeated regardless of how much pressure is being applied to the brake pedal until braking ceases or until the tendency to lock passes. Under normal driving conditions, with the road surface either dry or wet, the ABS system may not intervene for thousands of miles, although it is ready to operate when it is needed. In addition to increased vehicle stability and braking performance, the Teves ABS system enhances control of the vehicle during emergency stopping, provides more uniform tire wear, and reduces tire damage from wheel locking. ABS is quite different than the conventional brake system, although many components are similar. The similar components include a proportioning valve, disc brake calipers, rotors, and pads, and brake lines and hoses. Components unique to the Teves system include the electronic brake control module, or EBCM, wheel speed and toothed sensor rings at each wheel, a pump motor assembly, an accumulator and pressure switch, and the electrical circuit containing diodes, relays, indicator lamps, and fuses. These components are located under the hood, in the instrument panel, below the instrument panel, and under the car. A servo-type hydraulic cylinder replaces the vacuum booster used on conventional systems. A pump and motor assembly, located next to the hydraulic reservoir, draws brake fluid from the reservoir and maintains it at a pressure of 2,000 to 2,600 psi. This allows the system to react instantaneously when the brake pedal is depressed. The reservoir has a vented screw-on cap. The pump motor is controlled by a pressure switch and a pump motor relay. The pump motor pressure switch is installed in the pump assembly and contains 3 separate switches. One switch controls the pump motor relay. When the ignition is in the run position, voltage from the ignition switch flows through a 5-amp fuse to the pump relay coil. The relay coil ground circuit will close the contacts below a specific hydraulic pressure and will open when a specific pressure is exceeded. When the contacts close, the relay coil closes the contacts in the pump relay. The battery voltage is then delivered from a fusible link to the pump motor through a 30-amp fuse, causing the motor to run. The second switch in the pressure switch assembly monitors low brake system pressure and illuminates a warning light when a minimum pressure is not achieved. The third set of contacts in the pressure switch will illuminate the ABS warning light in the instrument panel when a minimum pressure is not achieved. The accumulator is on the high pressure side of the pump and motor assembly. Caution. Because hydraulic fluid is stored under very high pressure in the accumulator, care should be taken to release the pressure before servicing the ABS system. This is done by pumping the brake pedal at least 20 times until it becomes very hard. Hydraulic pressure in the accumulator serves 4 functions. These include the power brake assist, the rear brake application, the front and rear brake application during an anti-lock operation, and as many as 20 power-assisted stops if the motor and pump assembly fail to operate. If pressure is lost in the system, there will be a loss of the power assist in the front circuits and no rear brake operation. The front brakes will continue to operate, although brake pedal force and stopping distances will be greater. The accumulator is serviced by replacement, separate from the pump and motor assembly. The hydraulic assembly has a 3-circuit split brake system controlled by 2 pistons in the master cylinder and a control valve in the booster. The secondary piston supplies pressure through 1 circuit to only the left front brake. The primary piston provides pressure only to the right front brake. The main valve, which is controlled by the EBCM, allows the booster pressure to enter the front brake circuits during an anti-lock operation. The entire master cylinder and booster assembly is serviced by replacement. The hydraulic booster assembly is part of the master cylinder. A control valve in the booster modulates brake line pressure for 3 functions, including the power brake assist, rear brake application, and front brake circuit operation during anti-lock braking. When the brake pedal is depressed, a push rod transfers the motion to the booster, which then applies the brakes. The push rod and its attaching bracket assembly are serviced by replacement. The valve block contains 3 sets of valves. There is 1 pair of inlet and outlet valves for each hydraulic circuit: left front, right front, and rear. These are the valves which modulate pressure in the circuit to prevent wheel lockup. A 7-pin electrical connection is used by the EBCM to monitor and control the position of these valves. Under normal operating conditions, the inlet valves are open. When the system is in an anti-lock mode, hydraulic pressure in a particular circuit must be either reduced, maintained, or increased. The rapid opening and closing of this valve modulates the pressure. When the EBCM detects an impending wheel lockup, it sends a 12-volt signal to close the inlet valve in the affected circuit. Resistance on this line should be 5 to 8 ohms. The outlet valve solenoids are normally closed. When hydraulic pressure must be decreased in a particular brake circuit, the valve is opened by a 12-volt signal from the EBCM. Resistance on this line should be 3 to 5 ohms. In addition to the Teves hydraulic components, the ABS relay bracket, as well as the relays and fuses, are also located under the hood. The main relay supplies the EBCM with battery power needed to operate the valve solenoids during ABS operation. The relay also provides the instrument panel warning light with an alternate ground should the EBCM fail to operate. The front sheet metal ground provides the ground for several hydraulic unit electrical components, including the main valve, pressure switch, valve block, and fluid level sensor. The main relay is also grounded at this location. The positive junction block contains a fusible link which powers the 2 30-amp main relay and pump motor relay fuses. The pump motor and the front wheel speed sensor connectors are grounded at the EBCM. The brake system includes 2 warning lights in the instrument panel. A red light indicates either a reduced braking ability or parking brake engagement. This light cannot be illuminated by the EBCM. When the amber ABS light comes on, the Teves system is either partially or totally out of operation. If the amber light is on without the red brake warning light coming on, normal power-assisted braking operation is possible, although the ABS system will not function properly. Several electrical connections are positioned behind the instrument panel. A 6-way connector from the EBCM controls the amber anti-lock light, the system diagnostic link, the ignition switch run, the brake switch, and grounds from the fluid level sensor and pressure switch to the red warning lamp. There is also a 2-way connector behind the dash. This connects the ignition switch to a 5-amp fuse in the pump relay coil and another 5-amp ABS fuse in the EBCM circuit. This fuse protects the EBCM and will deactivate the ABS system if it is blown. A diode in the circuit protects the EBCM from damage by high current flow when the main relay is activated, and the EBCM grounds to illuminate the amber anti-lock light. This diode also provides a path to ground for the anti-lock light through the main relay when the relay is deactivated. The brains of the Teves system, the electronic brake control module, is located behind a panel on the right side of the passenger footwell. A screw hidden by the carpeting fastens the panel to the body. The EBCM monitors the entire ABS system and controls the operation of the system when it is required. The EBCM relies on inputs from each of the four wheels and feedback from the hydraulic unit to determine if the ABS system is working properly. In addition, using this data, the EBCM makes the decision to turn the ABS system on or off according to conditions. The last location for ABS components is below the car. 4 sensors, one at each wheel, consist of a permanent magnet surrounded by a wire coil. As a toothed sensor ring passes the stationary sensor, an AC electrical signal is generated. The frequency of this electrical signal is raised or lowered according to the wheel speed. This frequency is the information the EBCM uses to determine the speed of the individual wheels. The front wheel speed sensor toothed ring is mounted on the outer CV joint of the drive shaft. An aluminum bracket bolted to the steering knuckle holds the sensor. If this sensor is ever removed, it must be coated with an anti-corrosion compound before reinstallation. A 36/1000ths gap between the sensor and the ring should be maintained. Move the aluminum bracket to adjust the gap. At the rear wheels, the toothed sensor rings are inside the hub and bearing assembly. The speed sensors are housed in the suspension knuckle. The rear wheel speed sensor harness connectors are behind the wheels on the left and right body support rails. Under most circumstances, the ABS system is not in operation. To slow or stop the car, pressure on the brake pedal is transferred through the push rod to the booster. This opens the control valve. The control valve regulates hydraulic pressure from the accumulator. Pressure flows first into the boost chamber, then into the rear brake circuit through the open rear inlet valve in the valve block, to the proportioning valve, and finally to the rear calipers where the brakes are applied. The power assist is generated by the regulated pressure which pushes on the booster piston. The booster piston forces the master cylinder pistons to move, which in turn forces hydraulic fluid into the left and right front brake circuits. The fluid passes through the open inlet valves in the valve block and into the calipers to apply the front brakes. Regulated pressure also flows from the boost chamber through an internal passage to the main valve where it is blocked. This entire operation is referred to as a pressure increase condition because pressure on the brake pedal increases pressure throughout the system. When the EBCM detects an impending wheel lockup, it sends a 12-volt signal to the inlet valve, which closes it. Pressure in the affected caliper and brake line is trapped. No additional brake pressure can reach that caliper, regardless of how much pressure is applied to the brake pedal. This condition is called pressure maintain because the pressure in the affected circuit is maintained at a level just below that which would cause wheel lockup. The affected wheel will continue to turn, thereby maintaining traction with the road surface. If the pressure maintain condition is not sufficient to prevent the wheel from locking, the EBCM sends a momentary 12-volt signal to the affected wheel outlet valve. This signal opens the valve to create a pressure decrease condition. However, because the inlet valve remains closed, hydraulic pressure in the caliper and line is reduced. This allows the wheel to begin turning. At the same time, the EBCM sends a momentary 12-volt signal to open the main valve. Boost pressure from the main valve is then supplied to the hydraulic chamber at the back of the master cylinder pistons. If this boost pressure is greater behind the pistons than in front of the pistons, brake fluid will travel past the master cylinder piston seals and into the front brake circuit. When the hydraulic pressure equalizes, springs move the master cylinder pistons back into the bore toward the brake pedal. The main valve is designed to allow sufficient reserves even if the brake circuit pressure is lost suddenly during braking. If the wheel begins to spin too fast under the pressure decrease condition, the 12-volt signal can be either removed or sent to another valve to increase or decrease brake pressure as required. This pressure maintain, increase, or decrease cycle can occur as many as 15 times per second. The cycle will continue until the vehicle slows to approximately 2 miles per hour, or when the brake pedal pressure is released. TC owners will not notice any difference in brake pedal feel during normal braking. In an anti-lock stop, however, there will be a slight return kick in the pedal, followed by a pulsating feeling. A clicking sound may also be heard. All of these conditions should be considered normal. Before proceeding with the second half of this discussion of Teves ABS, take a break here. Review the information presented in the reference book and watch this portion of the presentation again. Make certain you understand how the system works before proceeding with the next half, which discusses diagnosing the system. Although the Teves ABS system appears to be complex, diagnosing and servicing repair problems are probably easier than you may think. The first step in diagnosing problems is to perform a complete visual inspection of all fluid levels, the parking brake, and the entire electrical system, including EBCM connectors, fuses, and fusible links. The two amber and red warning lights are important signs of electrical failure. If the amber anti-lock light is on and the red brake warning light is off, a failure in the electrical system is indicated. Diagnosing an electrical problem is performed by replacing the EBCM with a service module. While doing electrical checks, each pin in the connector should be inspected. All pins must be straight. Never probe the connector directly, as it may damage the pins. When diagnosing the hydraulic system, the two warning lights are again important. When both lights are on, either a loss of boost pressure or hydraulic fluid is the probable cause. Refer to the appropriate section of the service manual and follow the diagnostic decision trees to locate the fault. One of the most important diagnostic procedures you should follow is to verify the customer's complaint before choosing a mode of repair. For example, there is a distinct difference between a pedal which goes to the floor because of internal or external leaks and a hard pedal caused by a loss of boost. The customer may not be able to tell the difference. To verify the customer complaint, you may have to test drive the car. Although it is important for you to have a feel for the system, repeated use of the anti-lock function over a very short period can cause damage to the pads and rotors from overheating. Finally, always pump the accumulator down before removing any hydraulic part from the system. This is accomplished by pumping the brake pedal 20 times until very hard with the ignition key off. Remember, the accumulator stores brake fluid under very high pressure. The first step in diagnosing the ABS system is to make sure tire pressure and wear are uniform and that the brake fluid level in the reservoir is correct. Be sure to check the brake fluid level after the accumulator pressure has been pumped down. Next, make sure the two warning lights are functioning properly. Turn the ignition key to the run position and observe the bulb check cycle. Both lights should turn off within about 50 seconds. The pre-test of the hydraulic system starts with an inspection of all 4 brake assemblies. Make sure all components are in good operating condition. Inspect the battery. Be certain it is up to specification. Check the 35 contacts of the EBCM. If there are any damaged contacts, replace the entire unit. Verify the condition of the 7-pin connector of the valve block, the 2-pin connector of the main valve, the 5-pin connector of the combined pressure warning switch, the 2 and 3-pin connector of the reservoir warning switch, the 2-pin connector of all 4 sensors, and if the warning light is not working, check the 2-pin connector of the warning lamp. Make sure the motor relay and main relay are inserted in their sockets. Check the ground terminals of the electronic controller and the hydraulic unit. To determine the status of the Teves electrical and hydraulic circuits, use the anti-lock brake system service module. The face of the tester has clear instructions that will guide you through 5 separate tests. Disconnect the wiring connector to the EBCM and attach it to the service module cable. Attach the other end of the cable to the tester connection on the module. Begin with test 1. With the module power switch off, turn the ignition key to the on position. When the pump stops and the instrument panel bulbs have cycled through their check, the ignition light and the anti-lock light remain on. Disconnect the primary end of the coil wire. Turn the ignition key to the start position. During cranking, the ignition light will be off and the anti-lock lamp will be on. Now, reconnect the coil wire. The ignition key should be in the on position. Turn the module power switch on. All of the lights in test 1 wiring check should be on. Any light that is not lit indicates a fault in the circuit. Test 2 checks the condition of the speed sensors. Begin with the ignition key on and the module power switch on. Select the wheel sensor to be tested with switch A. Push and hold the speed sensor test button. Now rotate the selected wheel 1 turn per second. If the speed sensor is functioning properly, the light will come on. Repeat test 2 for the remaining wheels. The condition of the main valve is checked with test 3. With the ignition on, apply moderate pressure to the brake pedal. Push the main valve test button. The brake pedal will spring back slightly and the pedal effort will increase. If it doesn't, the main valve is bad and the booster master cylinder assembly must be replaced. Test 4 checks all of the wheel valves. With the ignition on, press on the brake pedal slightly. Select the wheel circuit to be tested. That wheel will be locked. Push the wheel valve test button and hold it for a maximum of 45 seconds. The selected wheel should now rotate. The wheel valve overheat light will come on if the test button is held too long. Look at the brake pedal. It should not drop to the floor. If the pedal does drop, or if the wheel does not rotate, that circuit is bad. Repeat the test at the remaining wheels. The final test is for the pump and accumulator. Start with the ignition off. Pump the brake pedal at least 20 times until pedal effort increases. Remove the accumulator and install the adapter. Then, reinstall the accumulator and connect the pressure gauge. Turn the ignition on. The gauge should read between 600 and 1300 psi. When the pump stops, Normally, within 60 seconds at room temperature, the pressure will be between 2,300 and 2,800 psi. Pump the brake pedal until the pump starts working again. The pump should restart between 1,900 and 2,200 psi. Turn the ignition off and pump the brake pedal 20 or more times to relieve pressure. Remove the adapter and gauge and reinstall the accumulator. If any of the components tested by the service module require replacement, refer to the service manual for instructions. It may be necessary to bleed one or more of the hydraulic circuits. Before installing a brake bleeder tank and adapter, clean the top of the reservoir and the cap to prevent contaminants from entering the system. During the bleeding operation, frequently check the brake fluid level to make sure it does not fall below minimum, especially when acting on the rear calipers. Bleed only one caliper at a time. Attach a clear plastic hose to the bleeder screw and feed the hose into a clear jar containing brake fluid. Next, open the bleeder screw. After a large volume of fluid has been forced through the brake system, close the bleeder screw. An air-free flow in the clear plastic hose indicates a good bleed. Before bleeding the rear brake circuit, check the fluid level in the reservoir. Make certain the reservoir has sufficient fluid in it before turning on the pump. Next, turn the ignition key to the run position. The pump motor will run and shut off when the system is pressurized. Attach a clear plastic hose to the bleeder screw at one rear wheel and feed the hose into a clear jar containing fresh brake fluid. Open the bleeder screw and hold the brake pedal lightly depressed until fluid free of air bubbles flows into the jar. Then tighten the bleeder screw and remove the hose. Repeat the procedure at the other rear wheel. Then check the pedal for travel. If travel is excessive or has not been improved, not enough fluid has passed through the system to expel all the trapped air. This concludes Part 3 of this videotape presentation. To get the most benefit, you should stop the videotape now and turn to Part 3 in the reference book. Once you've reviewed the information there, you may either rewind the tape and watch this part again, or you may proceed with the next section, which discusses the convertible and hardtops. Chrysler's TC by Maserati has both a luxurious, soft convertible top as well as a removable, body-colored hardtop roof as standard equipment. Like the classic vehicles of 30 years ago, the TC offers buyers an exciting, versatile, stylish package. The TC was created as a convertible from the ground up. It did not begin life with a roof, which was then cut off. From the beginning, the body was designed with the extra stampings and structural support members that assure good body fit and finish, and a minimum of squeaks, rattles, and groans. This extra strength is a must if the TC is to deliver the kind of performance levels it is capable of achieving. The basic frame construction of the convertible top is similar to the LeBaron and other convertibles. Inside, a luxurious cloth lining attached with Velcro hides the framework from sight. The inner lining also contributes to a quieter ride. Before lowering the top, make certain it is dry. To lower the top, lower both the door windows and the quarter windows. Release both front latches and lift the header off the windshield. Then close the latches again. With the ignition key in the on position, press the top button on the left side of the rear compartment to release the top rear bow. Lift the bow up to a vertical position. Press the tonneau button to unlatch the cover and raise it completely. Whenever the top is going to be lowered, make certain the well at the bottom of the window is clear of any objects that might interfere with the glass. Now, carefully stow the top in the well. Be sure the header latches are closed. Lower the cover, making certain both sides snap shut. There are 2 tonneau cover manual release cables located on each side of the rear compartment. Use these cables if the electric release or battery are not functional. When raising the top, all of the windows and both sun visors should be lowered. Press the tonneau cover release button and raise the cover. Lift the top and the rear bow to a vertical position. Then close the tonneau cover securely. Pull down slightly on the header, aligning the pins. Latch the top securely in the front, then insert and latch the rear pins. Press the top switch to pull the rear pins down. An electric motor located on the rear wall of the well is used to lock and release the top pins. If the power pull-down mechanism is inoperative, use the manual system located in the center of the trunk rear surface. Using a ratchet wrench or the wheel lug wrench, turn the mechanism until the top is in place. If the top is released manually, it must be locked again manually, or the electric pull-down will not cycle properly the next time it is activated. To determine the source of a water leak or wind noise, first visually inspect the areas listed in the customer complaint. Look for gaps or damages to the rubber seals around the doors and windows. To locate the source of a water leak, have an assistant look for seepage while you direct a stream of water over the suspected areas. Start from the bottom of the area and work toward the top. Make sure to test both the soft and hard tops for leaks following the same procedure. Another quick test for wind or water leaks is the paper test. Take a piece of paper about the size of a dollar bill and place it between the windshield header and the folding top header. Slowly pull the paper out. If it pulls out easily without much tension, the seal at this area may not be tight enough to hold out wind and water. Repeat this test across the entire length of the folding top as necessary. The chalk test is another way to check the header seal. Apply a length of black tape across the chrome header windshield rail. Mark the top header with a solid line of chalk. Then lower the top and latch it firmly in place. Then raise the top and inspect the tape on the windshield header to see if the chalk made uniform contact. If it didn't, this may be the source of the leak. A fourth test is the sonic or pressurized air test. Pressurize the car by turning the defroster blower on high and close the doors. Now feel for air leaks outside the car around the window seals and the header seals. If any leaks do occur, that will indicate a possible problem for repair. When the car arrives new at the dealership, the top fits correctly. Adjustments to the top should only be made in case of accident repair, replacement, or similar circumstances. There are 5 areas of adjustment for the soft convertible top. Adjusting one area normally affects the adjustment of the other areas. The dowel pins fit into holes in the header on the front windshield assembly. If they are not aligned properly, a side-to-side misadjustment in the top may occur. Latch hooks are used to fasten the top to the windshield header frame. The hooks can be adjusted to increase or decrease the amount of effort required to latch the top. Latches that are too easy to close may allow leakage at the front header. If the latching effort is too difficult, the customer will not be pleased. The front to center rails can also be adjusted. If the 2 rails are not aligned properly, leaking may occur. This area also contains the weather strip retainers, which house the weather stripping. These retainers cannot be adjusted. The cam on the rear rail is used to change the relationship between the top header and the windshield header. If it is misadjusted, leaking may occur at the windshield header and around the side windows. If the top header is too far from the windshield header, latching effort may be increased. The control links are used to locate the header and front rail in their correct positions. The links should be adjusted to put tension on in a rearward direction. The order in which adjustments are made to the top is important because each adjustment affects the positioning of all areas. The first adjustment to make is the dowel pins, if the pins must be moved side to side. Loosen the dowel pins and relocate them to the desired position. Then tighten the pins with a torque wrench to 110 inch-pounds. The second adjustment you may need to make is the latch hook. Loosen the set screw located in the housing of the latch hook. Turn the hook to either extend or reduce its length to decrease or increase latching effort. Then tighten the set screws. The third adjustment is the front to center rails. These rails should match the curve of the upper edge of the door and quarter window. If they do not, there will be poor sealing. The rails should form a straight to slightly bent line. You can lengthen or shorten the rail by turning the adjusting screw. This is opposite to a similar adjustment on the LeBaron convertible top. Turning the screw counterclockwise lowers the center hinge point. The next adjustment to make is the cam assembly. The cam will move the top higher and slightly forward or lower and slightly rearward in relation to the windshield header. Use an Allen wrench to adjust the cam. To move the header forward and up, turn the cam rearward. To move the header back and down, turn the cam forward. When adjustments have been completed, tighten the jam nut before moving the top. Test the adjustment by lowering the top and inspecting the fit. There should be tension in the control link. Add tension by pulling the link rearward. To do this, the top should be latched in place. Loosen both retaining bolts enough to permit moving the linkage fore and aft. Make sure the serrated plate is not sticking in place during this adjustment. Push up on the front to center rail as far as possible. This will allow the control link to find its natural position. To remove the hard top, lower both sun visors and all four windows. Unfasten the front latch handles and the two side latches just behind the quarter windows. Release the top pull-down mechanism by pressing the top switch. With the help of another person, lift the top off the car and place it on spacers or on the special rack. Take care not to damage the pull-down pins or latch hooks. When installing the hard top, the front and rear dowel pins and lockdown latches must align properly. Make sure to press the top switch to pull the top down completely. This concludes Part 4 of this videotape presentation. To get the most benefit, you should stop the videotape now and turn to Part 4 in the reference book. Once you've reviewed the information there, you may either rewind the tape and watch this part again, or you may proceed with the next section, which shows some of the unique features of the TC. Chrysler's TC by Maserati has numerous special design features which have been created to meet the car's unique requirements. Many of these features are modifications of existing Chrysler LeBaron convertible components, while many other features are exclusive to the TC. The standard radio on the TC, for instance, is Chrysler's Infinity 2 system. A compact disc player is part of the system. The radio and disc player are installed at the port of entry. Removal, installation, and service procedures on the sound system including the power antenna, are the same as on the LeBaron convertible. To remove the rear compartment speakers, snap off the decorative covers. To gain access to the top storage compartment speakers, the trim panel must be removed. To remove the CD player, take off the two bezel retaining screws. Unfasten the two screws which attach the disc player to the forward console. Pull the disc player out of the console and disconnect the interface cable. If battery power is disconnected, or if the mechanism is inoperative, the gas filler door can be manually operated by pulling a cable located on the right side of the trunk. Two pairs of gas-filled struts are located in each corner of the trunk. One set operates the trunk deck lid and the other controls the tonneau cover. The power-operated radio antenna is a telescoping type extended and retracted by a reversible electric motor. Remove the right side carpet cover in the trunk to reveal the motor assembly. The power window system on the TC is not interchangeable with the J-body system. On both models, a rack and pinion type regulator is powered with a high torque motor which is essential for cold weather operation. The power windows and door locks operate with the same switches and electric connections, although the switches have been modified for the TC. A new door lock switch has been positioned aft of the window switch. If service procedures require you to remove the bezel on the door, first remove the mirror control button, then pull up on the bezel. Notice that the passenger cannot operate the quarter windows. The seats in the Chrysler TC are one of this car's most remarkable features. Headrests are four-way adjustable. Hand-sewn leather covers are standard. A single button controls the recline action. Both the driver and passenger seats are power-operated in the TC. Both seats use the same mechanism with some modifications. 4 different adapter brackets are used on the right seat, and another 4 different adapter brackets are on the left seat. These adapters must be reused in their original location if they are ever removed. The windshield is manufactured in Italy for installation in the TC. However, it is built to Chrysler specifications and is the same size as the LeBaron convertible. Chrysler's TC by Maserati has a dual-path mount ISO strut system on the front and a trailing arm beam axle with coil springs on the rear. Gas pressurized shock absorbers are in all 4 locations. The independent front suspension system is similar to the LeBaron convertible. It is a McPherson type with vertical shock-absorbing struts attached to the inner fender reinforcement and the steering knuckle to provide upper steering knuckle position. Lower control arms are attached inboard to a cross member and outboard to a steering knuckle through a ball joint to provide lower steering knuckle position. During steering maneuvers, the strut, through a pivot bearing in the upper retainer, and the steering knuckle turn as an assembly. The coil springs are rated separately for each side of the vehicle. During service procedures where both springs are removed, mark the springs to ensure reinstallation in their original position. The rear suspension is a trailing arm solid type axle design. The axle assembly is fabricated from a transverse inverted U-section channel. An integral tubular stabilizer bar is positioned inside the U-section and attached to the spindle mounting plates at either end of the channel. The trailing arms and coil spring seats are welded directly to the channel. The assembly is located fore and aft by the blade-type trailing arms attached to body-mounted pivots. Lateral location is provided by a track bar. The rear suspension is equipped with coil springs and vertically mounted shock absorbers. All suspension mounting points are rubber isolated. Both the Maserati 16-valve and Turbo 2 equipped models have an equal-length drive shaft system with short, solid, interconnecting shafts of equal length on the left and right sides of the transaxle. An intermediate shaft is attached to a cardan joint with a stub shaft splined into the right side of the transaxle with a bearing and bracket assembly fastened to the right rear of the engine block. The drive shaft assemblies are three-piece units. Each drive shaft has a tripod joint, an interconnecting shaft, and a Resepa joint. The tripod joint is splined into the intermediate shaft on the right side. The Resepa joint has a stub shaft that is splined into the wheel hub. Although they appear similar and function in the same fashion, the drive shafts used on the Turbo 2 equipped car are different than the ones used with the Maserati 16-valve engine. The Maserati drive shafts are heavier duty and more rigid to withstand the higher torque produced by the 16-valve engine. Additional splines on both ends prevent the drive shafts from being interchangeable. The Chrysler TC has a unique wheel hop damper. The power steering system is similar to other Chrysler rack and pinion systems. A new power steering pump is not repairable. If this pump, reservoir, or cap fails or leaks, it must be replaced. This concludes Part 5 of this videotape presentation. To get the most benefit, you should stop the videotape now and turn to Part 5 in the reference book. Once you've reviewed the information there, you may either rewind the tape and watch this part again, or you may proceed with tape number 2 of this program, which discusses the engine and transaxles used in the TC. Please rewind this tape to the beginning when you're through viewing it.